and faster cornering. The solenoid is operated by an electrical signal from the Electronic Control Unit, or ECU. The ECU allows different modes of operation according to a selector switch on the dashboard. In the auto position, the dampening effect at the front wheels is increased at road speeds above 50 miles per hour. This improves vehicle stability at high speeds. The rear shock absorbers stay at their normal setting. The manual position has two settings, normal or sport. In normal setting, all shock absorbers remain at a rate suited to ride comfort. There is no change to the settings at high speeds. The sport setting increases the dampening rate of all shock absorbers. This is more suited to brisk driving with heavy acceleration and cornering.
Alright, arms or wishbone control arms or A-arms. They prevent forward and backward movement of the steering knuckle. Single arms or single point control arm uses only one contact point at the frame of the body. Rods transfer or prevent motion within suspension system. They have what you call tie rods, lateral rods, tension rods, control rods, panhard rod or what you call a track bar, steering rods, and strut rods. And more videos. Yay.
The major components of the suspension system must be firmly anchored to withstand the forces that occur in normal operation. Control arms fasten to a component like a rear axle assembly to the vehicle body, while allowing it to move as it needs to. Similarly with a steering knuckle. The arms must be strong enough to withstand the forces due to normal operation, but light enough to minimize the vehicle's unsprung mass. The front suspension can have one or two control arms. Parallel link front suspensions have two control arms. Vehicles with strut-type front suspension have only one arm. It can be a wishbone shape with two fulcrum mounting points, or straight with a single fulcrum. The inner end of the control arm is bushed to the vehicle body, and the outer end uses a ball joint to allow changes in the steering angle for turning. The major components of the suspension system must be firmly anchored to withstand the forces that occur in normal operation. Control arms fasten to a component like a rear axle assembly to the vehicle body, while allowing it to move as it needs to. Similarly with a steering knuckle. The arms must be strong enough to withstand the forces due to normal operation, but light enough to minimize the vehicle's unsprung mass. The front suspension can have one or two control arms. Parallel link front suspensions have two control arms. Vehicles with strut-type front suspension have only one arm. It can be a wishbone shape with two fulcrum mounting points, or straight with a single fulcrum. The inner end of the control arm is bushed to the vehicle body, and the outer end uses a ball joint to allow changes in the steering angle for turning. This rear-wheel drive vehicle has coil springs in the rear suspension. Therefore, special provision must be made to anchor the axle laterally and longitudinally. Trailing arms, or control rods, are used to position the axle longitudinally. They have flexible rubber mountings at each end where they anchor on the axle housing and on the chassis frame. They would allow the axle to move laterally if it were not restrained. Any such movement has to be controlled to keep correct alignment with the front wheels and the vehicle frame. This suspension system uses angled upper control rods to limit lateral movement of the rear axle during cornering. They also absorb the torque reaction forces, which limits rear axle windup during accelerating and braking. A panhard rod may be used to restrict lateral movement of the rear axle during cornering. It has bushes or mountings at each end where it fastens onto the axle and frame. This allows for vibrations and load while maintaining correct alignment. The axle may also be fastened by a Watts linkage. A lever mounted on a pivot near the center of the axle housing is connected by rods to the frame on each side of the vehicle. This maintains the axle alignment with the frame while still allowing the suspension to move vertically.
Steering knuckles can be found in many variations. They're either forged piece containing wheel hub or spindle, hole for axle to pass through, or it can be a cast iron or cast aluminum as well. Ball joints are swivel connections mounted in outer ends of the control arms. They have lots of these. Tie rod ends are ball joints. Remember parallelograms? All of those are ball joints. Some have grease fittings, which are called Zerk fittings, installed to allow for periodic lubrication. Ball joints, loaded supports weight of the vehicle. Unloaded doesn't support any of the vehicle. So let's say the upper ball joint doesn't really support the vehicle, but the lower ball joint does. It says it's a loaded ball joint. It said no.
Ball joints are swivel connections mounted in the outer ends of the front control arms and on the steering track rods and tie rods. They allow the control arms to move up and down with suspension deflection, and also let the wheel and hub assembly turn for steering. The ball joint can be a sealed, self-contained unit fastened to the control arm in a number of ways. It is made. Ball joints are swivel connections mounted in the outer ends of the front control arms and on the steering track rods and tie rods. They allow the control arms to move up and down with suspension deflection, and also let the wheel and hub assembly turn for steering. The ball joint can be a sealed, self-contained unit fastened to the control arm in a number of ways. It is made up of a pressed steel housing, fitted with sintered iron seats and a hardened ball stud. A taper on the stud fits into a mating taper on the suspension unit, and a rubber seal keeps out dirt and water. Some ball joints can be dismantled to replace the seals and the ball stud and allow for adjustments. Shims between the upper and lower halves of the joint allow free play to be controlled. Grease nipples can allow for periodic lubrication, but most joints today are sealed for life, and no regular maintenance is required. On tie rod ends, the ball joint is usually self-contained and attached to the tie rod by internal or external threads.
Bushings, they act as the pivot points and cushions at suspension fulcrum points. They are control arm bushings and strut rod bushings. Here on the left you see have a control arm bushing, and the right is a strut rod bushing. What's the difference? Anybody see the difference?
Bushing?
Just the bushing itself, right? Spring shackle bushings are molded to form two halves, and rubber bonded bushings are used for front eye of springs and control arm applications. Compliance bushings are molded with a voided section. This voided section allows the unit to comply with controlled amount of movement. Doesn't mean it's broken. It's supposed to be that way. A little slow.
Bushes or bushings act as bearings that suspend bushings.
I'm just waiting for this thing to catch up a little bit. Go ahead of us. Come on, little guy.
Bushes or bushings act as bearings at suspension fulcrum points to allow for movement of the component while maintaining its alignment. They can be metallic or made of rubber, nylon, or urethane. In commercial vehicles, metallic bushes are commonly used as shackle bushes for leaf springs. Any force applied to the bush acts through it to the body of the vehicle, which results in a harsher ride. The mounting pin on a metallic bush is usually drilled to allow for lubricating the bushes. Rubber bushes isolate noise and harshness and dampen unwanted vibrations. Rubber bonded bushes can be used to mount the steering rack to the vehicle frame. The rubber absorbs small impacts from the suspension action without transmitting them to the vehicle. Rubber requires no lubrication. Spring shackle bushes can be mounted to form two halves to fit into each side of the spring eye on the swinging shackle. With the spring loaded and the shackle plates tightened, the rubber is compressed in the eye and at the face of the plates. As the spring deflects, the rubber shears without tearing. Metalastic or rubber bonded bushes are normally used for the front eye of the spring at the fixed shackle point and also in control arm applications. The bush has a steel outer casing and inner sleeve. The rubber medium is bonded to both to provide flexibility between them. The outer casing is normally pressed into place in the component. Relative movement between the casing and the inner sleeve causes the rubber to shear without tearing. In control arm applications, particularly at the rear of the vehicle, the rubber arm may be molded with a voided section. This is known as a compliance bush because it allows the unit or component to comply with a controlled amount of movement in the direction of the void. The movement relative to the vehicle frame allows compliance or deflection steer of the road wheels when cornering. Since this influences the steering behavior of the vehicle, it is very important that the voided section is in its correct relative position.